Question 4, conservation of momentum. Sisaselana ka KZN question paper abayibhala ngo September 2020. This is an interesting question, a very interesting question. Uzo understand ukuthi ngichaza ukuthini in a moment. Now, like question 4, but a bullet of mass 5 gram is fired into a block of wood of mass 1 kilogram that is suspended by 2 light strings, right? So now my strings were to string 1, string 2 connected to this 1 kilogram block. So, but to pull a bullet into this wooden block. Now the bullet is stuck with the block, and the block and bullet system swings to a height of h. The height is 50 centimeters. Now there's a lot of conversions of okay, not a lot, but 2 conversions. The first one, it's this one. We don't work with our centimeters like physics, as well as gram change to ama kilograms. Yes. Now go 4.1, but the state second law in terms of momentum in words. Alright, Sitilana, the resultant or net force acting on an object is equal to the rate is equal to the rate of change of momentum, of the object in the direction of the force, of the force. This is how you define second law in terms of momentum, in the direction of the force. Now go 4.2, but you calculate the velocity of the block bullet system immediately after the bullet enters the block. This is the interesting part again. This is the interesting part for me. This is the interesting part. They haven't given us information about the initial velocity, which is the velocity calculated before, after this question, right? Okay, this is the interesting part again. Now, but there is a solution for this one. I'm just thinking, Guti, how do I approach this one again, Alright, energy principles. Yes, energy principles, especially what's this? Conservation of mechanical energy. Low wooden block it's suspended by 2 strings. It's stationary initial. Abasitsheli, but if ucabanga kahle, this thing yoba stationary, then le bullet liyashaya la, nalishaya liyenzani, you lift the wooden block to this height ga 0, let's see, 50 divided by 100, sithola 0.5 meters. That's why ngithilo centimeter kwamele umconvert. We work with ama meters. Bese le block na ifika la, the final velocity yoba ubani izoba ubani u0, right? Remember, but the block bullet system, so the block and the bullet combined, their final velocity at this height yoba 0. But initially, if we consider this as event A, then event B, the maximum that the height reached, then lagu A, when bullet enter the wooden block, the initial velocity for the wooden block and the bullet system izoba ne-value ke yona, right? Asho bathi calculated the velocity of the block bullet system immediately after the bullet has entered the block. Bullet ngena ku block, sifuna the velocity of the bullet and the block system when the bullet has entered la, meaning that the velocity yoba greater than 0 for this system, but finally na I reach at this height yoba ubani izoba 0 la is greater than 0. You have to find the initial velocity, but so sebenzisa ama energy principles, specifically mechanical energy. Kinetic energy plus mechanical energy initially is equal to the kinetic energy plus mechanical energy final. What is the kinetic energy initially? It's 1 over 2 m initial velocity squared, plus what is the potential energy initially? 0. There's no height. This is the reference point. The reference point equal to what is the kinetic energy finally? It's mgh ngoba we have a height now. Mechanical potential energy endaweni wrong, so the kinetic energy yoba 0 la ngoba the final velocity is 0 plus mgh. Then say a substitute 1 over 2. What is the mass of this system? The mass of the wooden block is 1 kilogram. The mass of the bullet is 5 gram. No, 5 gram komele simchange na 5 gram divided by 1000, so mchangela to ama kilogram plus low 1 plus low 1 kilogram, sithola ukuthi it's 1,005. so answer yethu la kuba 1,005. This is the mass of the bullet block system. V initial squared plus 0 anyway, lo 0 asingambhali now. Then kuba mass ilo 1,005, gravitational acceleration 9,8 to height to 0,5. Then we divide both sides again. Ngalo half 1,005. Siyabuya sithi half 1,005. Cancel. V initial squared is equal to. Then we calculate here manje. 1,005 9,8 0,5 divided by 1 over 2 1,005. Answer syntax error kuphi manje. Oh, bracket la, bracket mngana, bracket. So it's 9,8 the answer yethu la, right? It's 9,8. Ngaze ngihlulwe yiloko le cancel le half time cancel half 9,8 the answer yethu. There was no need for a calculator la. Then siyabuya ke manje sithi the square root of 9,8, it should be 3, something 3,13 as the answer. So V initial it's 3,13 meters per second. Now you answer yethu again. This is the velocity of the block and bullet system immediately after the block has immediately after the bullet has entered the blocks. For now, the speed of the bullet before it struck the bullet. Sizalage manje 4.1 siyaku 4.2.2 ke manje. Sila numbering yambe off kancane, but we are back on track my 4.2.2. all right, now so sebenzisa conservation of momentum. Ngifuna initial velocity, the velocity of the bullet before entering a wooden block, right? So and then the final velocity now sesengitholile lilo 3,13 ngoba siyoba ne combined mass between the bullet and the block. Angisho which azomove by the same speed or same velocity oyithula ama-blocks la. So the initial velocity nayi sifuna yona, the initial velocity of the block. So sebenzisa conservation of momentum. So EP initial is equal to sum of momentum final, right? Final. Therefore, mass 1, it's for the bullet. Velocity 1, initially, it's for the bullet as well. Plus mass 2, velocity 2, initial for the block. For the block is equal to mass 2 plus mass 1 V final for both. Actually it's a combined system, bohlangana, so bazoba ne-speed esifanayo, i-velocity efanayo. So mass of ilokanje, mass of our bullet 0.005, right? 5 gram, 5 kilogram. Okay, now convert all of 5 gram to a kilogram in total 0.005. Initial velocity, something engifunai, right? V1 initial plus what is the mass? 1. What is the initial velocity of the wooden block? It's 0 ngoba be stationary initial. So le plus lena usakhumbula isinikeza 1.005 final velocity. I do have ilo lokanje lo, ilo 3.13, right? So lana ngithola 0, ngisala nalo 0.005. V1 initial is equal to ya multiplier la 1.005 times 3.13, ngithola u 3.145, 6, no 7 to 6 now, 3 decimal places. I need to round this off, divide by 0.005, 0.005. So V1 initial is equal to bani 146 divided by 0.005. Answer 629.2, 629.2 meters per second. Oh yes, it makes sense. Bullet komele ligijime fast even. Komele ligijime fast. Now the mass of the block is doubled. How will the height now reached by the block be affected if it was shot by the same bullet as before? Will it be greater than, bakhuluma this height, will it be greater than, less than, or same as before? Mina ngithi izoba less than ngoba le wooden block seyasinda, so the bullet won't have the same effect as this block. So the answer, it should be less than. Okay, question 4 uphelela lana guys. I hope you enjoyed. I hope you took some value out of this discussion here too for today. Check out the description box for more questions and waphendulile for the question paper. For now, I'm saying peace, but ungakhohlwa ukulike, ukushare and ukusubscribe. But there's also a link to another YouTube channel, Yama lessons only in creative. Check it out now. Please subscribe to that one. I'd appreciate it. Now we again logo. So guys, for now I would like to say peace.